All right, so next we're going to start learning about sample space. And I want to use this clothing example to give you an idea of what sample space is. So look on your notes, make sure you have your writing utensil ready to go. A school uniform requires students to choose from a blue, green, or white polo shirt and either khaki shorts or navy shorts. A polo is randomly selected from a drawer with one of each color. So we're going to record the options in a list below. A pair of shorts are randomly selected from a drawer with one of each color. We're going to record those options. So here, the possible options for the shirt are either going to be blue, green, or white. And the possible shorts are khaki, or navy. Oops. Now we're going to use the tree diagram below to show the two events and the total possible outcomes when selecting a polo and a pair of shorts. Okay, so let's pretend you reached in the drawer. You pulled out a blue shirt. Now you have options. You can either wear khakis with it or navy. What if you pulled a green shirt? Well, you still have the same two options. You would either wear khaki or navy. And if you pulled a white shirt, you still have those same two options of khaki and navy. So please write those down. What we're noticing is you could have a lot of different combinations of clothes just with these 5 items. So the next part down says to list the total possible outcomes when selecting a polo. Well, this is 1, 2, 3, 4, 5, 6. So we have 6 possible outcomes. Make sure you write that down. Pause if you need to. All right, I had to erase that and then I scrolled it up a little so we could see part D. So we're going to use the tree diagram or list to determine the probability of selecting a blue polo with khaki shorts. So we know there's 6 possible outcomes. Green with khaki, green with navy, blue with khaki, blue with navy, white with khaki, white with navy. So if I want to know the possibility of blue polo with khaki shorts, blue with khaki. So this is one possible option out of 6 total options. So we're kind of doing this like a part to whole ratio. There is a 1 out of 6 chance of being able to have a blue polo with khaki shorts. This brings us to sample space. Make sure you're ready to fill in the blanks. The sample space describes all the possible outcomes of an event. Sample space can be displayed using a list or tree diagram to determine the probability of simple or compound events. Compound over here. So we're going to use our understanding of lists and tree diagrams to represent the sample space. So a fair coin is tossed 3 times. What are the possible outcomes? How many total possible outcomes are there? Well, first toss, you're either going to get heads or you're going to get tails. That's the end of it. If I toss again, so say it landed on heads. If I toss it again, it's either going to be heads or tails. Well, what if I did tails? Same thing. If I toss it a second time, it's either going to be heads or tails. All right, now I want to toss it a third time. So I'm going to make my tree here. And if I had landed on heads the first time and heads the second time, there's a 1 out of 2 chance it's going to be heads or tails here. Same thing over here. Oops. Heads or tails. Same thing here. Heads, tails, and here, heads, tails. So these are all of the possible outcomes that could happen. We have 1, heads, 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 2, heads, heads, tails, heads, tails, heads, and heads, tails, tails. Then tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So there is 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So I want you to write that in here as well. 8 possible outcomes. So when you flip that coin 3 times, these are the only 8 combinations you could end up with. Okay, I'm going to go through these next 2 together with you through the video, and you're going to try number 4 and 5 on your own. So for breakfast, Jamie can choose from cereal, eggs, or a muffin. She also can drink coffee, orange juice, or milk. What are all of the total possible outcomes? All right, so you could do this with the tree diagram if you want, or you could make a list. It's up to you. So let's start with her things that she can eat. So cereal. So she can have cereal, and with that cereal, she can drink coffee, or she can drink OJ, or she can drink milk. So that's a couple different options. Well, what if she decided to have eggs? She could have eggs with coffee, OJ, or milk. Well, what if she decided to have a muffin? She could have a muffin with coffee, OJ, or milk. So these are the possible combinations: coffee and cereal, cereal and OJ, cereal and milk, eggs and coffee, eggs and OJ, eggs and milk, milk and coffee, muffin and coffee, muffin and OJ, or muffin and milk. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. So I followed the directions, I listed all the possible outcomes with my tree diagram, and I know that there are 9 possible outcomes. Okay, next one down. Amanda will roll a number cube and flip a coin. If Amanda rolls the number cube once and flips the coin once, what are the possible outcomes? And then it says in which the number cube lands on an odd number. All right, so odd numbers on a cube: 1, 3. Actually, I'm not going to write that there. Oops, that's okay. 1, 3, and 5. Because 2, 4, and 6 are even, we can't use those. So if we roll a 1, then we flip the coin, it's either going to be heads or tails. If we roll a 3, flip a coin, it's either going to be heads or tails. And if we roll a dice and we've got a 5, it's either going to be heads or tails when we flip the coin. So 1, 2, 3, 4, 5, 6 possible outcomes when we have a number cube that lands on an odd number. All right, so you have now 3 examples of how to make these trees. You're going to do number 4 and number 5 on your own. So please stop the video after you have gotten everything down that you're supposed to have. Work independently on 4 and 5. Come show me so that I can see if you are ready to move on to your next activity.